Having studied the external features of the midbrain, let us now move on to the internal features. Internal features of the midbrain are studied by taking sections of the midbrain at two different levels. One at the lower level passing through the inferior colliculi and the other at the upper level passing through the superior colliculi. In case of medulla and pons, I had actually dealt with each section in a separate video. But here I'll be dealing with both the sections in the same video because there are too many similarities between the sections. So it becomes easy for you to compare and contrast. Within the midbrain, irrespective of at what level you take the section, we have ascending and descending tracts, a special collection of grey matter known as tectum and substantia nigra, some precerebellar nuclei like red nuclei as well as reticular formation, and of course the cranial nerve nuclei of third nerve, fourth nerve and the mesencephalic part of the fifth cranial nerve. The sections of the midbrain at the level of superior and inferior colliculi are taken at the levels shown here. Let us go on to study its features. This is the outline of the midbrain. Irrespective of what level you take the section, the outline will have the same layout. In fact, it almost resembles an imprint a person leaves on his chair if he was sitting with a wet bottom. So all the features which you are seeing right now are going to be similar between the two levels of midbrain sections. So let us find out what they are. Right in the middle, we have cerebral aqueduct surrounded by a mass of grey matter known as periaqueductal grey or PAG. We can divide the midbrain into anterior and posterior parts by an imaginary plane passing just in front of the cerebral aqueduct. The anterior part is made up of a pair of cerebral peduncles and the posterior part is known as tectum. Each cerebral peduncle is made up of a crus cerebri anteriorly, tegmentum posteriorly, connected by a band of grey matter called as substantia nigra, which is darkly colored. You will notice that the two crus cerebri are separated from each other. That area, the gap between those two forms the interpeduncular fossa, whereas posteriorly the two-sided tegmentum have joined together to form a continuous mass. Tectum is made up of corpora quadrigemina, that is superior or inferior colliculi, and a pretectal area. So obviously, if the section passes through the level of inferior colliculi, the corpora quadrigemina will include inferior colliculi at that level. If the section is taken at the upper level, then we will see the superior colliculi here. We had studied earlier that BrainStem in the general arrangement video, that BrainStem will have an anterior basal part, a central tegmental part and a posterior roof plate part. So in case of midbrain, the basal part is occupied by the crus cerebri, which has all the descending tracts from the cortex. The roof plate is represented by the corpora quadrigemina. The rest of the area is the tegmentum, which has the cranial nerve nuclei, reticular formation, the precerebellar nuclei and various ascending and descending tracts. Let us now move on to study the section of midbrain at the level of inferior colliculi. So you will notice that we have the crus cerebri, we have the substantia nigra, we have the cerebral aqueduct surrounded by the periaqueductal grey. Posteriorly, the corpora quadrigemina segment is represented by inferior colliculi. On either side of the periaqueductal grey, we are seeing the tegmental region and the pretectal region. So this design is similar as what we had seen earlier. Now let us see the features within the periaqueductal grey. In fact, the only two regions which show variations will be within the periaqueductal grey as well as within the tegmental region. So within the periaqueductal grey, anterior to the cerebral aqueduct on either side of the midline, we find a pair of trochlear nuclei. These belong to somatic efferent column. The neurons within this nucleus will be supplying the superior oblique muscle, which is an extraocular muscle. It supplies only one muscle. Further posteriorly, that is dorsolateral to the cerebral aqueduct, we find a pair of mesencephalic nuclei belonging to general somatic afferent column. This is the uppermost trigeminal sensory nucleus. We had already dealt with it in the Pons, saying that this is a triply unique nucleus in being the only collection of first order neurons within the central nervous system, only place where we have unipolar neurons within the CNS, and only neurons which form a part of the monosynaptic reflex in the supraspinal segment, that is the jaw jerk. Now, from the trochlear nuclei, the trochlear nerves first will wind little laterally, then they pass medial to the mesencephalic nuclei. As they descend towards the midline, they exit from the dorsal aspect just below the inferior colliculi. But what you must observe here is, before they exit, the right and left nerves are crossing with each other. So the fibers which have started from the right nucleus will be supplying the left superior oblique, and the fibers which are starting from the left nucleus will be supplying the right superior oblique. This is a unique feature. In fact, no other spinal or cranial nerve will have this crossing. The nerves which are starting on the right side will supply the right structures, and nerves which are starting on the left side will supply the left structures. Next, coming to the tegmentum region, we find the same band of lemniscus, which includes medial lemniscus, trigeminal lemniscus, spinal lemniscus, and the lateral lemniscus. Only difference is, instead of being arranged mediolaterally, here they are arranged almost ventrodorsally. Then anterior to the periaqueductal gray, we are finding the decussation or decussating fibers of the superior cerebellar peduncles. This is the place where the efferent fibers from the cerebellum also decussate. Also the afferent fibers to the cerebellum, like ventral spinocerebellar tract fibers, they will also be decussating before reaching the cerebellum. The rest of the lateral tegmental area will be filled by reticular formation. We also find a set of tracts in the anterior tegmental region. Just in front of the trochlear nuclei, on either side of the midline, we find medial longitudinal fasciculus. Further anterior to them, we have a pair of tectospinal tracts, and further anterolateral to them, we have a rubrospinal tract located. And more laterally, we have a pair of central tegmental tracts, which are again situated within the tegmental region. So, quickly summarizing what we saw in the section of the midbrain at the level of inferior colliculi, the cranial nerve nuclei which we saw at this level were belonging to 4th cranial nerve and mesencephalic nucleus of the 5th cranial nerve. We found the band of lemnisci containing all the 4 lemnisci, and we found the decussating fibers of the superior cerebellar peduncle. One decussation, that is decussation of the superior cerebellar peduncles. Now coming to the section of midbrain at the level of superior colliculi, again note, you are seeing the crus cerebri, you are seeing the substantia nigra, you are seeing the tegmental region and the pretectal region. Of course, the colliculi here will be the superior colliculi, and you are of course seeing the cerebral aqueduct surrounded by periaqueductal gray. Now coming to the features within the periaqueductal gray, anterior to the cerebral aqueduct, we have a pair of oculomotor nuclei belonging to the somatic efferent column, but the two-sided nuclei will have merged along the midline, so almost resembling like a single mass. Posterolateral to these oculomotor nuclei, we have accessory oculomotor nuclei, otherwise known as Edinger-Westphal nuclei. They belong to general visceral efferent column. Now, oculomotor nuclei will supply most of the extraocular muscles except superior oblique, which was supplied by trochlear, and the lateral rectus, which was supplied by the abducens. Edinger-Westphal nuclei, on the contrary, will supply the intraocular muscles, that is sphincter pupillae and the ciliaris, through its relay in the ciliary ganglion. Dorsolateral to the cerebral aqueduct, we have the same pair of mesencephalic nuclei. We are now seeing the uppermost part of the mesencephalic nuclei, which belong to general somatic afferent column. From the oculomotor nuclei, we have the oculomotor nerves emerging. They pass through the tegmental region and through the substantia nigra to exit on the medial aspect of the cerebral peduncle along the medial sulcus. So as they emerge, they will be found as a content of interpeduncular fossa there. Within the tegmentum, we again see the band of lemnisci, including medial lemniscus, trigeminal lemniscus, and the spinal lemniscus. You will notice that lateral lemniscus is missing here because lateral lemniscus, being a part of the auditory pathway, will have exhausted by relaying in the inferior colliculus at a lower level. So at the higher level here, we don't find lateral lemniscus. Next, in front of the periaqueductal gray, we find a pair of decussations, a dorsal tegmental decussation and a ventral tegmental decussation. Dorsal tegmental decussation is actually formed by the decussating fibers coming from the superior colliculi, and then they will be reaching to the spinal cord. So they are the fibers of tectospinal tract. And the ventral tegmental decussation are the decussating fibers of the rubrospinal tract. Anterior to the superior colliculi, in the pretectal region, we find a pair of nuclei known as pretectal nuclei. We will talk about them a little later. Rest of the lateral part of the tegmentum is occupied by the reticular formation. In front of the oculomotor nuclei, on either side of the midline, we find the medial longitudinal fasciculi, as we had seen in the lower levels also. But the most important prominent feature of the section of the midbrain at the level of superior colliculi, which I have reserved for the last, is the presence of a large red nucleus within the tegmentum of the midbrain. These are actually visible as reddish colored nuclei in a fresh cut midbrain section, about 0.5 centimeter in diameter. In fact, the presence of this nucleus will tell us that this is the section taken at the level of superior colliculus. So quickly revising what we saw in the section of the midbrain at the level of superior colliculi. So here we see the cranial nerve nuclei for the third nerve and the mesencephalic nucleus. So at the inferior colliculi, we had seen the fourth nerve and the mesencephalic nucleus. Here we are seeing third nerve nuclei with the mesencephalic nucleus. Band of lemniscus is found, but band of lemniscus at this level will have only 3 lemnisci because lateral lemniscus will have already exhausted by relaying in the inferior colliculus. At the level of inferior colliculi, we had only one decussation. Here we are seeing 2 sets of decussations, a ventral tegmental decussation of rubrospinal tract fibers and a dorsal tegmental decussation of the tectospinal tract fibers. It's easy to remember if you notice the relative position of the superior colliculus with the red nucleus. Superior colliculus is more posterior compared to the red nucleus. So the dorsal decussation belongs to the superior colliculus, that is the tectospinal tract fibers. Red nuclei being more anterior, their fibers decussate more anteriorly, forming the ventral tegmental decussations. Plus we find a pair of pretectal nuclei here and a pair of red nuclei here. So these are different features compared to the section of the midbrain at the level of inferior colliculi. Hope you enjoyed this video. Thank you. You can visit this site for other videos on neuroanatomy. Thank you.